Hey everyone, welcome back to another video of the interview preparation series. In this video, we'll be coding the factorial problem using recursion. If you haven't watched the previous video, go ahead and watch it to get a better understanding of this video. In this video, we'll cover three concepts. One is solving the factorial problem using integer approach. Two is understanding the drawback of solving the problem using integer approach. And three, we'll find a solution to this drawback. So let's begin with coding the factorial problem using the integer approach. So here I have opened up Eclipse and I have created my class inside a package. So let me start with importing. Right? So what am I going to use this util.star for? I'll be using it to use my scanner. Alright. So now let's come to coding my function. So I'm going to call it factorial and I'm going to pass an integer n to it, right? So what should be the base condition? Let's say if n is equal to 1, I'm going to return 1, right? Now let's say we have n is equal to 0. Let's say we can consider that condition too, because sometimes they might ask us to calculate that. So we're going to return 1 in that case, right? Now comes the logic part. So as we have discussed before, we're going to multiply n with the factorial of n minus 1. So here we have written our base condition, and this is the logic of the rest of the code. So let's say we pass a number and let's say that's 3, all right? So it's going to come inside the function. It's going to see that this condition is not satisfied. So it's directly going to go to this place and it's going to call 3 into factorial of 2, right? So what happens in this case? Again, factorial of 2 is called and the function is continued till we reach 2 into factorial of 1. Now when we reach factorial of 1, when this function is called again, then what happens? It's going to satisfy this base condition and it's going to return 1. So as and when that returns 1, the function is going to return the value 1 to the function where we called factorial of 2. Right, so factorial of 2 is 2 into factorial of 1. Now that is going to calculate it as 2 into 1, which is 2, and it is going to return it to the function 3 where we pass the value as 3. So it's going to compute it as 3 into factorial of 2, which is 3 into 2, and it's going to give us the result as 6. Right, so let me just quickly go ahead and write the main function. Alright, okay. I think I've put an extra bracket over there. That is not needed. Right. So what am I going to say? I'm going to tell the user that give me a value of n. Right. So I'm just going to say enter the value of n. And now the user is going to give me the value of n. And I'm then gonna compute it and give the answer. The factorial is, I'm going to give an output, the answer. Now what is this answer going to be? I'm going to call the function factorial passing the argument as n, right? And I'm going to print that out. And let's say it's a good practice to always close your scanner, right? So now we have coded the factorial problem. So let's say I give an input of 3. So it's giving the factorial is 6. Say I do it again. I give 5. Right? The factorial is 120. Now let's say I give the input as 14. Okay. So remember this value, right? It's giving the value of factorial of 14 as this. Let's say I try some larger number or 25. Okay. So it's again giving this value, which is 8 to 9 digits long. This might look right now, but we'll see later. All right. We'll find that out if this works or not. So this is the factorial approach using the factorial problem using the integer approach. So let's say I give 10, it's going to give me the answer. This is the answer for 10. Okay. So this method works just fine, right? It's giving us the correct output, and even for greater numbers, you can see that it's giving us the right output. Right? It looks as if it's giving us the right output. We will verify that later. So far we feel that the factorial problem, the factorial code using the integer approach is working just fine. But let's explore further and see what happens when we give some other values, right? Now this approach has a major drawback. You might be wondering what it could be, because the program which we coded works just fine. Well, it does not. It fails in many cases. Do you know how many digits an integer can accommodate? It can accommodate a maximum of 8 to 9 digits. So let's say I'm trying to calculate the factorial of a number which is longer than that. What happens then? It goes into negative numbers. So that is not right? It does not give us the right answer. So what do we do then? Now let's say I'm trying to calculate 14 factorial. The value of 14 factorial is 8717 829 1200. Alright. So as we can see, this is 11 digits long, and I am trying to calculate the factorial of a number which gives us an answer which is 11 digits long. But we know that integer can accommodate only around 8 to 9 digits. What do we do then? You might say we can use long, right? But this will work in this case. What happens when we try to calculate the value of, say, 25 factorial? 25 factorial is 26 digits long. And let's say, what about 50 factorial? 50 factorial is 65 digits long. Or let's say 100 factorial. 100 factorial is 158 digits long. So what happens when we try to calculate the factorials of these numbers? We can't just say, okay, we don't have any such data type, so we cannot calculate it, right? So in this case, we use something called big integer. Now you might be wondering what this big integer is. Big integer is a class in Java. Now let's understand a little more about what this big integer does. So as I said, big integer, this is a class in Java which is used for, right over here, it is used for mathematical operations. In which cases? Let's say in cases which involve very large numbers which cannot be accommodated in integer or long or any other primitive data type, right? So big integer uses the math library. So for using big integer, we need to import java.math.star. All right. So now let's code the same factorial problem using big integer and see how it's done. Okay, so now we're going to write this code using big integer. So for that, I've already created a class called Factorial Big Integer. So as I said, for big integer, we need to import the math library. And for our scanner, I am importing the util library. All right. So now let's create our function. I'm going to call it public static. The return type is big integer. Integer. And let me call it long factorial, right? And I'm going to pass an integer to it. All right. Now, what is this big integer? Big integer is a class in Java, and as you can see, we denote it like this with capital B and capital I. So just like any other class, when we want to use a big integer variable, we need to create an object for that. So let's start with our base case. So let's say if n is equal to 0 or n is equal to 1, then I'm going to create a big integer object. So for that, I'm going to say big integer answer equal to new big integer, and in quotes I'm just going to give 1, right? So that's it. You don't have to do anything else, just create an object and the initial value should be 1. It should return 1. So I'm going to do that, and I'm simply going to return this answer, this object. Alright, and since the return type is big integer, there will be no issues because this object type is also big integer. Now let's look at the rest of the code. So for that, again, we need to have an object to return this object. This object has scope only inside this if condition, right? So I'm going to go ahead over there and I'm going to say I'm creating another object, big integer answer 2, let's say, and in that what am I going to store? I need something which is of the type big integer. Now let's say you have n into n minus 1. Which of these two is of the type big integer? N is of the type int, n minus 1 factorial, that is of the type big integer. So I'm just going to go ahead, I'm going to call this function again. I'm just going to copy it from there. So I'm calling the function again for n minus 1. Now what should we return? We have the value of n, we have the value of n minus 1 factorial. We just need to multiply these. Now big integer class has inbuilt function which lets you do that. So what am I going to multiply with what? So I'm going to multiply answer 2 with LTITLY, okay? I'm going to multiply answer 2 with the value of n. Now I simply can't just put n over here because this is of the type integer, right? And this will not be allowed. You see, this will throw an error, right? So what am I going to do is I'm just going to get the value big integer dot value of, and I'm going to say n. So this will, take away that problem, and I can easily multiply n with my answer 2. Now let's come to the main function. I'm just going to go ahead and get it from this one, right? So yeah, here we go. So what are we doing? We are getting the value of n, and now this part is not needed, right? I'm just gonna directly print this over here, so let's remove that. And alright, so long factorial, we're passing n, right? Cool. So what happens over here, we have called the long factorial function and we have passed n as the argument, and this is going to directly give us the output of this. Now let's execute this and see. Let's try with smaller value. It's giving 120, that's right. And let's try with, let's say, 10. Good. And let's try with 14. Right. So you see, now this is giving us the right value. All right. What was the previous function doing? It was giving us some other value. Let's try with 14 again. See, this was giving us a completely different value because wrapping up was taking place. The digit limit was being exceeded, so the number of digits was getting wrapped up and it was giving us the wrong answer. But now in this case, this is giving us the right value, 14. And let's try it with 25, right? So it's supposed to give us 26 digits. So let's count that. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 21, 22, 23, 24, 25, 26. All right. So now this is giving us the right answer. So we can see that the big integer approach is quite efficient. It gives us the, it's quite accurate. It gives us the right answer even for very large values of n. So that was it, the two methods of solving the factorial problem. I hope you've understood how to code the factorial problem using the integer as well as the big integer approach. Please let me know what you think of this video in the comment section below. Also feel free to ping me anytime if you have any doubts. And if you like this video, please give it a thumbs up and also subscribe to this channel to watch more of such videos. See you all in the next video. Stay safe. Happy learning.